Welcome to my second video on exploratory data analysis. The first part was just a slideshow showing what EDA is and explaining certain aspects of data cleaning, feature engineering, and so on. And this one I've picked out a small housing price data set from, I think it's from an area in Arizona, America, and I think it only has like 5,000 columns or 5,000 rows and 16 columns. And we're just going to do some basic EDA, exploring the data, how to use pandas and different features of, different functions of pandas to explore the data. And here I titled it EDA Part 2 for beginners because I'm just trying to build your foundations for this before we get onto harder data sets, doing further cleaning. So my next video will probably be further, like proper deep dive into a big data set and doing data cleaning on that. And then probably the video after that will be using a housing price data set again and using linear regression to predict house prices. And yeah, so let's begin. I'm using Google Colab Notebook. You can use Jupyter Lab, Jupyter Notebooks, anything you want, but I prefer Google Colab. I'm just more used to it. First thing I'll do is do import. So import pandas as PD. That's the first one. The most important for this notebook is pandas. And PD is obviously just like shortening it. You write it as PD instead of pandas. Next import numpy as np. We're not going to use numpy in this video, but it's just getting used to writing these imports. Then we do import matplotlib.pyplot as plt, and then finally import, I think I'm going to use seaborn, so seaborn, not C's, seaborn as sns, spelling mistake. There we go. And then obviously there's other imports you can do for further analysis in the future, but these are the four main ones as we're doing basic. Pandas is the most important one for now. And yeah, just run this cell. If you're using Jupyter notebooks or Jupyter Lab, you might need to pip install. There's something you just do like pip install. I'm sure there's tutorials on YouTube and elsewhere to see how to do that, but sometimes your imports won't work right away. So yeah, okay, let's add some more coding cells. First thing we're going to do is bring in our data. So my data is stored on my computer. You can bring it from your Google Drive and so on. And if you click here, the files, so you have different things here. This shows you, all your notebook and all the names you have and stuff. Here, if you click here, you'll go onto your computer's files and you can select your dataset from there. I've already downloaded it, so I'm not going to click on that. Here, you refresh, and if you click on this, you can mount your Google Drive, hit onto Google Colab, and you can just quickly, work on anything that's on your Google Drive. So first thing we're going to do is using pandas function. We're going to create a data frame. So I'm going to write. You can name this anything you want. It can be like data or house data, whatever you want. But you'll probably see that most people do df as data frame. So we're working with a data frame. Instead of writing data frame, we just write df, and then we're going to equal that to pd dot read underscore csv. So pandas function to read the file we have, the comma separated values. And all you have to do is write the path where your data is. And obviously mine's here. You could just go here, click copy path, and paste it in here. When I paste it, did I run the first cell? Yep. If you run that, there's a tick, so it worked. All you have to do is, if you write df here, it will show you your data frame. So here we go. It shows the first 5 values and the last 5. It gives you all the different information in MLS, sold price, zip code, longitude, latitude. This is the data frame we have. There's 5,000 rows, 16 columns. It's not a huge data set, and I'm pretty sure this one is quite clean. It's not a, I think there's been some work done on this already. And yeah, you have all sorts of different features, taxes, year bill, and so on, and a lot of information you can see here. And let's just make a subheading here. So you want to go up here, quick click text, 2 hashes, and then write understand. So I'm just going to do the first subheading as understanding the data. Capital data, understanding the data. So here you go. And anything below this, unless there's another heading, will be under here, so it'll keep your work a lot neater, but you don't have to do something like that. But yeah, let's do it. Understanding data. First thing you can do with Pandas is see how many rows and columns it has. Here it does say rows and columns, but sometimes you don't want to print this whole thing, and you just want to, like, when you do some sort of work on your data frame, you just want to see what's changed and how many rows and how many columns you have, what you're working with. So all you have to do is df.shape. If you run that cell, 5016. So the first index is the row. The second, the 0th index is the row, and the first is the column. And as it says up here, 5000 rows, 16 columns, 5016. That's the shape. So yeah, and then next thing you could do is, here it shows the first 5 and the last 5, but if you want to just see like the first 5, first 10, first 20, like a specific amount, you want to specify what you want to see, you can just write df.head. If you do .head, it's going to show you the first 5. That's what it's built in as. So it'll be 0, 1, 2, 3, 4. There's 5 of them there. And then inside the brackets, you can specify how many you want to see. So let's just say we want to see the first 7. If you run this again, you go 0, 1, 2, up to 6. So there's 7 of them here. That's the first 7. So it's up to you. You can choose, you know, when you use .head, it's going to be from the beginning and how many you want. And if you want to see towards the end of your data set, you can use .tail. So you go df.tail, and it's same as head. If you don't specify an amount, it's going to be the last 5. Let's see. Yep. Up here was 495, 4995, 4996, and so on. 1, 2, 3, 4, 5. There's 5. And then let's specify. Let's say we want to see the last 3. Let's see. Yep. 97, 98, 99. These are the last 3, and that's what it brings out. So that's just to view your information. You can do certain different things with that. Let's add some more code cells. What else can we do with Pandas? What other information can we get? If we write df.info, it's going to print like a concise summary of the data frame. Let's do that. Here we go. So it gives you the columns, all of these are the features. There's 16 of them: MLS, sold price, zip code, and so on. And it says like 5000 non-null, so it tells you all these, and then it tells you the data types. So integer, if you go on MLS, these are integers. Sorry, here, integers. Float for sold price, these are float, there's decimal points, and so on. And there's some objects. So let's focus on the bathroom one for example, because bathroom, it says data type is object, but when you go on bathrooms, if you look at the first 7, there's only integers. So to explore this a bit further, what you can do is just view bathrooms as separately. So all you have to do is df in square brackets, just write bathrooms like this. That's the feature. So whatever feature you want to look at, just data frame bathrooms. That's the feature we want to look at. And then you click .unique. And then when you do this, you can see the different values inside of your bathroom. So all the unique values that appear inside of this bathroom column. So 10's unique, 2's unique, 3's unique, 5 unique. You know, these are all the unique ones. So let's see how many there are. Okay, so it returns an array, you know, 10, 2, 3, all of these are unique. And then when you look at it deeply, you can see that there's 3.5, which is quite confusing. There's none, there's missing values, there's 2.5, and then 36. That's a crazy outlier. So you can get a bit more information by doing stuff like this. And when you're analyzing it, you may be thinking, how can you have 3.5 bathrooms? Does that make sense? I mean, it doesn't really make sense. And what can you do with this? Maybe you want to round all of these numbers up to the next value. So up 1 or down 1, it's up to you. And you want to work with these none values. You want to either remove them, fill them, whatever you want to do. And these outliers are important. So what do you do with outliers? And I'll say it here, I'll mention it early on. With outliers, outliers will affect the model performance. And so machine learning algorithms job is to generalize for the population but outliers will skew the results. So your machine learning algorithm is wouldn't care, like, if that makes sense. Like, even if there is a house with 36 bathrooms and it's true in that area, but it doesn't represent the rest of the population. Look, there's twos, threes, five, six. This is so out of range, and it will skew the results a lot, and it will affect the way your machine learning algorithm works. And machine learning algorithm's job is just to generalize for the population. So let's say you have 20 houses in one area with 3 to 5 bathrooms, and then you have 2 houses with 100 bathrooms. Those 2 aren't going to be representing the other 20. It's going to skew the results by a lot, a huge margin. So I would say, right here, always remove outliers for your models, just for your models. You can keep them for obviously visualizations, this, that, whatever else you want to do with it. It can give you a lot of other information. Outliers are important, but to feed into your model, I would say always remove outliers. And yeah, that's what I'll talk about for outliers. And so we've got the unique values. These are all the unique values. And if you just want to see how many of them are there, just do df. Same thing. Bathrooms. We're looking at bathrooms. So here it says .unique, but if you do .n unique, it's just going to give you the number of unique values it has. So there are 20 different unique values, and if you count all of these, there's 20. There's 20 different values here. Okay. So what else can we do? If you want to get more information out of your features, you could do describe. Describe. So to do that, you just do df.describe. df.describe. Oh, what have I done? df.describe. And when you do this, it gives you, all your. This is going to bring you the numerical features, so your floats and integers. Obviously, look, if you look, there's no bathrooms because there's other values in here. Clearly, you can't return that. You can't have minimum, maximum for object types. So it's going to give you the numeric categories, and it gives you like the count, mean, standard deviation, minimum, maximum, and so on. Like, it gives you a lot of different information you may need for statistical analysis. And one thing I like doing with this describe method is df.describe again. But if you do .T, this is for transpose. It's right here, transpose. And if you know what transpose is for a matrix, if you've done linear algebra, you know that in a sense the transpose of a matrix is like an operator which will flip the matrix over its diagonal. So think about it as the diagonal, and then all your columns will become your rows, and all your rows will become your columns, if you get what I mean. And we'll just quickly see how that works here. If we run this cell, yep, all the rows have become columns. They're up here now, and all our columns have become our rows. And I feel like this is a better way to visualize these counts, means, and all of these things, because I don't know, it just looks a lot cleaner visually to me. You can choose which one you like. There's no difference. It just formats it in a different way. But yeah, I prefer the just to transpose it. You can obviously transpose a lot of different data sets, but all you have to do is .t, and it works. Okay, what else can we do? And so we're describing, when we describe, it's describing all the values. And let's say we want to just focus on one thing, just like up here we focused on bathrooms to get more information out of it. Let's say you're working with sold price. Let's say sold price. All you have to do is df, as before, you put in square brackets and write sold price, and then .describe. So it's just gonna describe, give you the description of the sold price, nothing else. And when you're doing individual analysis on different features, you don't want to see everything. Just sold price, and you have all the count, mean, all of this for your sold price. So this is kind of useful as well. And yeah, that's about the basics of the just exploring the data. I mean, understanding the data. Next part we'll go to is, let's do another subheading, data to hash data cleaning, and we're going to dive into some of the basics of data cleaning here. And this is why I do subheadings when I don't want to review the other information. There we go. Understanding the data, 13 cells, it's all in here. And data cleaning is going to have its own cells. So data cleaning is usually say a very long process. It takes up a big chunk of anything you're doing, like data analysis, data science, machine learning. In anything, data cleaning is probably one of the longer aspects of it. Like in machine learning, working with algorithms, just predicting is a lot easier and quicker than doing the data cleaning itself. So if you're gonna focus on anything while studying, make sure you understand data cleaning really well. Is probably the hardest part. And if you don't have good clean data to feed into your machine learning models, you're not going to have good predictions. You're not going to have good results. So yeah, data cleaning is very important. And let's go through some of the basics of data cleaning. Let's just say we want to look at duplicates in our data. So duplicates are obviously going to skew the results. It's going to affect it a lot because you're going to have the same values and it's not going to be representative. Let's say over here, this could all be duplicated, and you have, like, let's say 5 of these. What you want to do is remove the duplicates. And to check if you have any duplicates, all you have to do is df.duplicated, and then df.duplicated and .sum. So if you just do .sum, run the cell, 0. So for our data frame, we don't have any duplicates. Like I said, I can't remember where I got this data set from, but it was pretty clean. It was on my drive. So what we can do to demonstrate it is create our own data set. Let's do a dictionary with keys and values. Like our keys will be like movies and the values will be the different types of movies, for example. So I'm going to name this data frame to our new data frame. So let me name this df2, data frame 2. And we're going to make a pandas data frame, pd.dataframe. So you have to write pd.dataframe to create a pandas data frame. And it's going to include, so like I said, let's do 3 columns. And we'll do movie, genre, and IMDb rating. So inside of this, we're going to make a dictionary. So if you do these curly braces, you're creating a dictionary. And all you have to, let me just space it out a little bit. So let's start, like I said, 3 columns: movie, genre, and IMDb rating. So there's going to be 3 keys. The first one is movie, and then we'll do the values for this, and the values of this. So the first movie, let's think of a movie, Avatar. That's our first movie. Second movie, let's do Avatar again. And third movie, let's do, what should we do? Star Wars. And then we can do another movie, Incredibles. And then let's do another one. What could we do? Spider-Man. So we created our little dictionary for movies. First movie is Avatar, second is Avatar, Star Wars, Incredibles, Spider-Man. Alright, put a comma here. Next, so we said we're going to do movies, the genre, and the IMDb rating. So here we're going to do genre. Let me do genre. And let's see what genre these can be. So Avatar. So if you look at it in this way, so Avatar, the first value is going to be the first value here. It's going to be linked to that. So the second one's going to be the second value in genre, third one's the third value, and so on. So Avatar, the first value is going to be, let's just say Avatar's what, science fiction, action, whatever. I'm just going to say a random one. I'm just going to say action. Let's say action is what Avatar is. And then Avatar's action again, so because we have another Avatar there. Star Wars, let's say Star Wars is sci-fi. Okay, Star Wars is sci-fi. Incredibles, let's just say, I don't know, cartoon. I don't know what to write for that. And then Spider-Man, we just write comic. So 1, 2, these all align. Incredibles, cartoon, Spider-Man, comic. Yep, another comma here. And then our final key this will be IMDb rating. IMDb rating. What can we put as the ratings? So Avatar, let's give it a rating of 8.8 out of 10. Let's say these are out of 10. So Avatar's 8.8. And then we had, what do we say? It was Star Wars. Let's give Star Wars an 8.3. And then we had Incredibles. Let's say Incredibles is 7.5 as the rating. And then let's say Spider-Man was 9.2. So we have the movie, the genre, and the IMDb rating. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So our dictionary, our new data frame should be created. If I run this cell, okay, no mistakes, and let's just do df2. Here we are. So we've created our data frame: movie, genre, IMDb rating. The first one is Avatar Action 8.8 rating, Avatar Action 8.8, Star Wars Sci-Fi 8.3, and so on. So we created our data frame, and we see that we have a duplicate. Okay, so this will. Let's see what if we do df.duplicated dot sum. What do we have? Oh, sorry, that's df. This is df2. There we go. The value is 1, so we have one duplicate here. This one is duplicated, and the value is 1. Let's just say, let's go back to our data frame. Let's add one more. At the end, let's add another Star Wars. Star Wars. And let's say Star Wars was sci-fi. Do sci-fi. And then the rating was Star Wars was 8.3. 8.3. So we added another thing. Run this cell. Run df2. There we go. Star Wars Sci-Fi 8.3. Star Wars Sci-Fi. So let's see how many duplicates we have now. It's still 1. Did I spell something wrong? Star Wars. Oh, I didn't put the thing here. It has to all be the same, obviously. Let's run it again. There we go. And df duplicated 2. So now we have 2 duplicates. And so how do we drop these duplicates? So one way to drop it is, or the way to drop it is just do df. So we're working with data frame 2. So df2 dot drop, and then underscore duplicates. And when we do this, it's gonna drop our duplicates. Let's see what happens. There we go. So we had this one as duplicated. It's no longer there, and this one duplicated, no longer there. We only have 1, 2, 3, 4. Four movies left, and there was 1, 2, 3, 4, 5, 6. There were 2 duplicates, and they're removed. So that's how to drop them. You just do df2 dot drop duplicates, and that's what happens. However, I want to show one thing here. If I do df2, let's view it again. It's not updated, so we still have the old one without the duplicates. So there's 2 ways to update this. One way is to go, let's say df2 equals. So you assign it the new df2 equals the df2.drop duplicate. So equals this thing here. So if you run this, now that's what df2 equals. And if we do df2 again, there we go. That's updated. But I don't like that method. I like there's a different df2. Let's comment that out and then rerun. That's our data frame. Let's see. Yep. Another way to do this is just do df2 dot drop underscore duplicates. And then what you want to do is inside of this, write in place equals true. When you do this, it automatically updates it. So if we run this, and then let's return df2, run this df2. There we go, it's updated. So all you have to do is in place equals true inside of the brackets, and then it will automatically update it. You can do both ways, you know, do it like this yourself manually. df2 equals df2.drop duplicates. That's your new data frame. That's how you update it. Or just write in place equals true. So that's 2 ways to update it. And what was I gonna say? One thing I missed from earlier is, let's go back to it. Actually, wait, no, I'm gonna skip that for now. I'll say it afterwards. what can we do now? Let's go back to our original data set. We do the so we looked at duplicates. Now we want to look at missing values. And we just do df dot is not na dot sum. Let's see. So in our original data set, we have no missing values, and all of them, apart from lot acres, has 10. It says 10 there. So to drop this, all you have to do is do. So we don't want missing values. So there's different ways to come up, deal with missing values, and one of them is, just do df dot drop na, df dot drop na, and then as we said before, you have to update it. You write in place equals true. Let's run this, and then we do df dot shape. I don't want to print the whole data set out, so let's just do the df dot shape just to see how many rows and columns we have now. So we went from 5,000 to 4,990, so it dropped 10 rows. These 10 here have been dropped. So one issue with this is it drops the whole row, and it shouldn't be doing, like, sometimes you don't want to do that. There could be a lot of vital information. You could have like 100 columns. If there's one missing value in one of them, you remove the whole row. So there's other methods to go about this. Like, you want to fill it instead, you want to do something else instead. So let's just do an example of that. Let's get our little data set. Print this over here. This is our little data set, and then let's run this. Okay, so let's say there's a missing value here. If you write none here, run that. df2 dot df2 dot is now dot sum. Let's see what comes up. Oh, sorry. Oh, when you don't put the brackets, it'll tell you like true, false, false. If it's missing, it's going to be true. Obviously, this one's missing. It's true. But let's do it like this. So IMDb rating has 1 missing. The other movie and genre has no missing. IMDb rating has 1 missing. So if we do df2 dot drop this, drop na. So drop a in place equals true. Let's see what happens. And I just print df2. We can see that so the first one was missing. Avatar for the first one was missing. In this data frame, we know there's duplicates. Avatars duplicated, but the first avatar had the IMDb rating missing, so it removed the whole row. The IMDb rating was missing, but it removed the whole row. So that's one way to do it. Let's say you don't want to do that. What you could do is instead fill it. So let's just comment this out. Or don't even need to comment out. Let's just copy it. Make it easier for you guys. Back to it. This is our data frame again. We've ignored all of this here. Just comment this out. Okay, so it's none here. Let's say we don't want to remove it. We want to fill it with something else, another value. So you can fill it with a certain value you want, or fill it with the average of the column or the rows, whatever. So it's up to you. You can choose something. That's one way to do it. And to fill, all you have to do is do df.fill na, df.fill na, and then you can specify inside what you want to fill it as. Let's do fill now 0. That's the first one. My bad. It's df2 for our data frame 2. There we go. So avatar, it was missing. We filled it with 0. Let's say we want to fill it as, avatar. We know that avatar got a rating of 8.8. Let's just fill it with 8.8. Let's see what happens. 8.8. Let's change this to 9.7. Let's run that. 9.7. So you can just, change it yourself. And yeah. So that's about it for data cleaning. It's just very basic. There's a lot to data cleaning. I can't explain it all in one video, but these are some of the things that you could do. And obviously in my next video and further videos, we'll do further data cleaning and diving more deeper into it. Okay, another section. Let's minimize this one. So understanding data cleaning. Let's do another text. Oops, what have I done? Let's do feature engineering. Feature engineering. Okay. Back to this. Feature engineering. Alright, so for this one, let's go back to our original dataset, df.head. Let's view the first 5. This is our original dataset. So we have MLS, sold price, zip code, longitude, latitude, lot acres, and so on. All of these. Okay, so what can we do with this? One thing we can do, let's say you want to, I could have maybe talked about this earlier, but I'll talk about it here. Locate. So I look and look. So you locate something. So iLook is, you know, index location, and this is a way to, you know, locate certain columns and rows. I'm just going to do a very quick example of this. Let's just say we have our data frame. All you have to do is df.iLook, and then we specify the index, because we're using iLook, it's index location. We have to specify the index is at. So if we do 0, let's see what it gives us. So for 0, it gives us these values. These are the values it returns. So MLS is 200 and whatever this is, 53 million or 5.3 million for sold price, 85,637 for zip code, and that's our 0th index. And that's this row here. It has given our first row. Let's change this to, let's just say 3. What is it going to give us? 219. 1, 2, 3, 4, 5, 6, 7. So 21 million. This is probably 4.5 million, and that gives you this one here, this row here. So it gives you the specific ones for that you want in your data frame, and you can do further things with this. Let's say you want to work out. I'll comment this out and do it below. Let's just say df.iLook, and you want to get, let's say you want to get the first and the second one. So 0, 1. That's all you have to do. df.iLook. Oh, sorry, I see what I did. You have to do, obviously, it's another bracket inside. 0 and 1. Let's run this. Okay, the first and the second. Let's just say the first and the fourth one. Let's do like this. Oh, this will be the fifth one. Maybe 1, 2, 3, 4, 5. Fifth one. First and the fifth one. And yep, first, fifth. So it returns different values, and you can obviously add more in between. So let's say this and fourth. First, second, and fifth. First, second, fifth. So this is useful just to locate different rows, I guess, and choose specific ones you want. And I'll dive more deeper into iLook and lock in my further Pandas video, but that's the basics for now. What else can we do with our data? So one way to view all your columns is just to write df.columns, and if you do this, it gives you all your columns in one array, I guess. So MLS, sold price, zip code, all of it is here. These are all your columns. These are all your features, and this is useful because you can just pick it, makes different subsets, pick and choose the ones you want. And here's an example I'll say. So let's create a subset of this data frame, df_subsets, and let's equal it to, so we have df of so we have all the features here. We just have to copy this. See, copy and paste it there, and then this is the subset we created. And when you create the subset, obviously you choose which ones you want. Let's say we don't want the HOA, floor covering, fireplaces, kitchen features, garage, square foot, and so on. Let's just delete all of this. Let's delete it. That's an easy way to remove features, and then run this. We run that. and then just do df underscore subset. Let's view this. df underscore subset. There you go. So you only have MLS, sold price, zip code, longitude, latitude, lot acres, taxi built, bedrooms and bathrooms. Let's just say we don't want longitude, so lot acres, longitude, latitude, and zip code. Let's remove all of this as well. There we go. Let's run this. There we go. We're only left with 1, 2, 3, 4, 5, 6. So our subset is this. You can do different subsets, drop features if you want. You know, just choose the ones that you want to work with or feed into your model. And another way to drop is, let's just say you have the original data set, this whole one. All you have to do is df.drop, and then we do, oops. So let's just say we want to drop MLS. We're looking at the original one. You know what? To make it easier to view, we just do df.head again. So this is our original data set. MLS, sold price, all of this, all the 16 things are here, features. Let's say we don't want MLS. We say, okay, MLS is has a lot of useless information. It's not going to affect our predictions in the future, and we don't want to use it. All you have to do, df.drop, specify what you want to drop. So MLS, and then the axis is in. Axis equals 1. The axis, so rows equal, write this as a comment, rows equals axis 0, and columns equals axis 1. So the rows are axis 0 and columns are axis 1. So MLS is the column, it's a feature, so it's in axis 1. And then finally, as we talked about earlier, we want to update it, so in place equals true. So every time we bring in the df data frame, every time we view it, MLS is not going to be there because it's updated here. Let's do this, and then let's just view it, df. There we go. It's removed, MLS is removed. 4,990 rows from before when we dropped the rows, and then columns, 15 columns, it was 16, we dropped MLS, now we have 15 columns. So that's one way to drop it. And let's say you want to know, like, what features to drop and how to go about this. We could do like different methods to understand your data more, visualizations and so on. I'm not going to get into too many visualizations, but I'm just going to do a quick correlation matrix. Let's just do df.correlation, and then we'll do plt.figure. So I'm just going to make a figure of a correlation matrix and a heat map to just visualize it a little bit and see the relationship between different features. We have different columns. So we have the fig size, and what should we do at fig size? We'll do 16 and 12. That's the fig size, and then sns.heat map. So we'll do a heat map using Seaborn, and correlation true, and let's see what this gives us. So you can just create a small, this is very basic, you can do different things with these. You can do, okay, this one's a bit too big, let me change the size of it. Let's do 8, do 12 and 8. Let's see how this looks. Okay, that's better. You can see it better now, and you just have all the relationships between different different features. So sold price compared to bedrooms. How is there a correlation between them? 0.12. If you look at the key here, 0.12. It's a small correlation. We have lot acres. It's the higher one, 0.33. That's pretty high. And you could just think, okay, the bigger the land size, the larger the land that you're buying, is higher the price, I guess, stuff like that. And then you have bedrooms and lot acres, here, small correlation, and so on. There's like different ways to view this, and when you're looking at this, you can determine which features you want to remove. And there's something called right here, multi collinearity. So this is something you want to look for, and correlation matrices help you look for this. And this, I'll just write it here, refers to a situation which two or more independent variables, two or more independent variables in a ML model are highly correlated with each other, so highly correlated. And so if they're highly correlated, it's going to affect the results, and it's going to be, you're going to have like unreliable estimates as well. So we're going to dive more deep into multi-collinearity, and I suggest you read into it. But this is like a very small explanation or description or definition of it. And yeah, so that's our heat map. It will show different relationships with different features, and using this you can pick out, what's important for your, let's say you're predicting sold price. You might want to make a correlation matrix with the most strongest correlation, all the features with the strongest correlation with your sold price. And obviously, if you look at this, it doesn't show the categorical data. Maybe if you one-hot encode things, we're going to get into one-hot encoding in the future, but you can do different things to view those and feed into your algorithms. So yeah, you can see different relationship with different things. Sold price to taxes, sold price to latitude, longitude, zip code, all of this, and so on. So what should we do next? One more thing I'll do is get back into these features. I'll do it here. So we have sold price, zip code, all of these, yeah. Let's say you want to add new columns. So I'm just going to show a quick way to do that. DF, and then as before, when we did this, and for example we did bathrooms, it showed what it was. But we want to make a new feature. Let's just say greetings, df.greetings, and we want to assign that it as let's just write hello. Let's see what happens, and then obviously write df at the bottom and run the cell. So we have all these features, and at the end it added greetings as a feature, new column, and all of it has hello. So why is it important to know how to add and remove columns and features? So let's say you want to create a new feature using these, maybe kitchen features, fireplaces. You want to combine them, or kitchen features and something else, or I don't know. You can look at square foot and price, and you want to work out a new column that is new column. Let's just write here, new column equals price per square foot. So it'd be like PPSF, price per square foot. You might want to see how much each house is per square foot, the value of it. So let's just do one simple one. Let's just say the age of the house. We have the year built. For the year built, you can do a lot of different analysis to see, how the year is built is affecting, the price of the house. But let's say you want to make a new feature. You don't know the age. It just says the year built. So this is built in 1941, but you don't know the age. We're in 23 now. So you have to, instead of individually calculating it, you can just make a new column that says the age of it. So we start with df. So as before we did with greetings, we just write age. That's what I want to name it, and then we assign it to. So we're in 2023, and then we want to do the way to do it. Obviously, 2023, and we want to work out the difference between the current year, 2023. Take away the year it was built. So we do take away df of year built. 2023 minus df of year built, and then let's see what comes up. Let's run this cell, and yeah, the age. So if you look at 1941, this house was built in 1941. To get to 2000, that's 59 plus 23. Yep, 82. And then 1997 to 2023, 26. So you can see the ages of each house as well, and maybe this will be an important feature to feed into your ML algorithm. you know, it could give you a lot of results. Like the older the house, maybe the cheaper it is, because it's, you know, broken down, old, not, you know, being looked after, missing a lot of, you know, modern features. Or it could be like a, you know, proper antique, proper, you know, old nice house that you wanna, you know, that's probably worth a lot. Like there's different things you can get out of this. Maybe the newer houses with new features, you know, modern houses, maybe they cost more, and you can see like the younger ones probably cost more, for example, and so on. So that's another thing to think about. But yeah, so and finally, above I talked about I think I'm done with the video, but above I've talked about outliers. I haven't done too many visualizations in this, but I'm just going to do a small box plot to look for outliers. SNS.box plots, and then we'll do x equals df of, let's do a box plot on the sold price. Let's just say we're looking at the sold price, and then see what information we can get out of this. The sold price, and let's run this. So it's a very simple, ugly box plot. You know, sold price. There's no, you know, no other labels, nothing. You know, no different colors. Just a simple box plot. But as you can see, there's, you know, these values here, for example, are way different to the other houses. So majority of them are over here, and you have like a lot of them that are probably going to skew the results. And if you do certain visualizations like this, or work out the standard deviation and other statistical models, you can pick out the outliers and remove them. And like I said earlier, to feed into an ML algorithm, you would most likely always should remove outliers. And yeah, so that's it for my video today. Showed what I could, and I'll be uploading this code, feature engineering, close that. So understanding data cleaning, feature engineering. I'll upload this code and the data set onto my GitHub. I'll link it in the description of my YouTube video. Well, I hope you enjoyed this video, and I'm hoping to make more in the future. And this was a beginner's guide. I'm gonna dive deeper into pandas in the future, do more proper data cleaning, maybe do like more, or you know, maybe make dashboards in the future on Power BI or Excel dashboards, and just do all sorts of data things. And I want to be working with a lot of machine learning algorithms and doing predictions for different things. So for example, house prices, you know, do some customer segmentation and so on. A lot of things we could do. Thank you for watching my video, and I hope you enjoyed.